Hey everyone, in this lesson we're going to be talking about how do we use the quadratic formula. In a prior video, I already went over the derivation, like how do we come up with the quadratic formula by using coefficients a, b, and c, and by using the method of completing the square to get the x by itself. Now this video is basically focusing on, okay, now that we know the quadratic formula and where it comes from, how can we use the quadratic formula to be able to solve any quadratic equation that we want? So the reason why the quadratic formula is so great is because it allows you to solve any quadratic equation. No matter how complicated it looks, no matter what the coefficients look like, as long as you have the values of a, b, and c, and you can simplify, you can basically solve it by using the quadratic formula. So I'll remind you guys on what the quadratic formula is in a minute. But the hard part about using the quadratic formula is basically the simplification of this basically uh, expression once you plug in the values of a, b, and c. So as long as you remember PEMDAS, right? So PEMDAS, please excuse my dear Aunt Sally. Then you should know that the order of operations still apply. So the first thing we need to do is parentheses and then exponents, which means that we need to simplify whatever's on the inside of this radical first. So let's say we wanted to simplify this, right? So x is going to be equal to negative 13. I'm going to leave that alone. Plus or minus the square root of 13 squared. That's going to give me 169. That's just 13 times 13. And then I need to figure out what is the multiplication of 4 multiplied by 7 multiplied by 6. And when I pop that into the calculator, I get 168. So it's basically 169 minus 168. And that came from 4 times 7 times 6. Okay? This is all just calculator work. So then I put it all over the bottom, which is 2 times 7, which is 14. Okay? So far, so good. I can simplify the inside of this radical, right? So 169 minus 168, that's just going to give me a 1. So it's just negative 13 plus or minus the square root of 1, and then all divided by 14. So if you can simplify this, you basically have solved the quadratic equation and found the solutions for whatever equation this was from. So the value of x would be equal to negative 13. The square root of 1 is just 1, right? So it's going to be negative 13 plus or minus 1, and then all divided by 14. So when we split it up into two equations, my two values of x are going to be split up as negative 13 plus 1 divided by 14, and then negative 13 minus 1 divided by 14. So when I do that, I'm going to have two answers. The first answer is going to be x is equal to negative 14 divided by 14, which is going to give me a negative 1. So that's one of my roots, one of my solutions. The other solution would be negative 13 plus 1 divided by 14, which is going to give me negative 12 divided by 14. And if we simplify that, that's going to give me a total of negative 6 over 7. So the point is that the hard part of the quadratic formula is basically simplifying this nonsense. If you understand PEMDAS and if you simplify it properly, then you can get any answer, any root to any quadratic equation that you plug into. We'll do one more really quick, and then we'll jump into some actual examples. I have 3 examples for you that are recycled from the last lesson. So basically, let's say we wanted to simplify this out. So again, same thing. The first thing we want to do is PEMDAS, right? First, we have to square that. Then we have to multiply this and do the parentheses, which happens to be whatever's inside of the radical. So on the outside, I have negative 17, which is just a positive 17. So that's just 17, right? Plus or minus radical, whatever 17 squared is. So when you pop that into the calculator, if you guys have a nice calculator you can plug it into, I didn't make you guys memorize 17, but you can do 17 times 17 on the calculator and it'll give you 289. So 289. And then we're going to subtract, in this case, or actually maybe not subtract, because we have a negative 4 multiplied by negative 13, right? So negative times a negative is a positive. So that'll give me a positive 52. And then I multiply that by 24 again. So now we got to do times 24. And when I multiply this times this times this, I get 1,000 positive 1,248. So yeah, it's kind of a little bit of simplification, but I mean, if you guys have a calculator to work with, it shouldn't be that bad. When we add 1,248 to 289, we get 1,537. So that's 1,537. Just we'll write that in a little bit. And then on the bottom, I get 13 times 2, which is 26. So let's simplify that out. So x is equal to 17 plus or minus the square root of that number, which was 1,537 when I added those two things up, and then all divided by 26. Okay? So I could actually keep on going a little bit if I take the square root of that. Let's see if it actually goes in nicely. 1537. It is actually some weird decimal. So we can't simplify this in terms of actually finding like the decimal of it, but we could actually simplify it, but trying to figure out, okay, what can I divide so I can actually simplify this a little bit more. So if I do that on the side, let's just say, wait, not square root. So forget about this problem for right now. I'm going to do a little factor tree on the side, 1537. Is there anything that I can divide by that? Okay, so I checked out those numbers, like basically what can actually, to see if I can simplify this out a little bit. What actually multiplies to 1537, and the two numbers that multiply to 1537 are 29 and 53 when I do a factor tree. That means that these two are actually prime numbers. I cannot break these up anymore besides this number and 1, which means that I cannot simplify this radical at all. Basically meaning that we're kind of done. So we can't simplify the radical anymore. We basically leave it as our answer. So the two answers are x is equal to 17 plus or minus the square root of 1537 divided by 26. So this is basically, if we plug that into the calculator, so take the square root of 1537, add 17, and then divide it by 26, we get one answer. And then if we take the square root of 1537, and then take 17 minus that, and then divide it by 26, we get our other answer. But the point of this is the hard part about simplifying using the quadratic formula. Now we're going to be doing some real examples that you could actually verify. So the quadratic formula basically looks like this. And there's several different ways that you can go ahead and memorize it. If you guys were in class, I would definitely make you memorize this. Absolutely memorize this formula because it always works no matter what. And the formula is x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. Now, if you're trying to figure out how the heck am I ever going to remember that, if you remember the song Pop Goes the Weasel, that is a very good way of remembering this formula. So if you remember Pop Goes the Weasel, Pop Goes the Weasel, this is the exact same thing that we're going to be using to memorize this formula. So it's x equals opposite b plus or minus square root of b squared minus 4ac all over 2a. X equals opposite b plus or minus square root of b squared minus 4ac all over 2a. It's the easiest way to remember it. If you just say that over and over again like 30 times, I guarantee you'll probably memorize this formula. So it's opposite b plus or minus square root of b squared minus 4ac all over 2a. Okay, now that you know the formula and you practiced it 30 times, sure you did, these are the only steps. Step 1, set the equation equal to 0, which you've done before. Identify coefficients a, b, and c because we need those for the formula. And then 3, plug it in and simplify. That's all we're going to do. So example number 1. I recycled this problem from another problem that we've done in the past. So that way you can check your work. For this example number 1, we're going to be trying to solve this by basically doing the x by factoring. And then on the other side, we're going to be trying to solve this by doing the quadratic formula. And then you can see that it actually does work. So let's check this out by factoring. So if you try to factor this, it's actually factorable. That's why I'm letting you know that you can do it by factoring. You multiply a times c and put it on top. So we put a 9 on top. I put negative 10 in the bottom. I want two numbers to multiply to the top but add to the bottom. That'll be -9 and -1, right? These two multiply to 9 but add to -10. So my two factors are x and x equals 0. Don't forget the equal 0 part. This is -9, this is -1. So I have two answers. My first answer is x is equal to +9. My second answer is x is equal to +1. After I solve each one of these using the zero product property and setting each one of these equal to 0, I get these two answers, right? So this is basically factoring and doing the zero product property. Now we're going to be using the quadratic formula. For the quadratic formula, we need several things. We need to figure out what is the value of a, b, and c. So it needs to be in standard form, right? So the value of a, in this case, the number in front of the x squared is the value of 1. The value of b is the number in front of the x, which in this case, b is equal to -10. Don't forget the negative and the positives. They do make a difference. And the final thing is the value of c, which is the number without a variable. In this case, it's equal to +9. Now, since you are a great math student and have already memorized the quadratic formula by now, you should know that x is equal to opposite b plus or minus the square root of b squared minus 4ac all over 2a. So once you plug it into the formula, all you need is to simplify it and you have your roots. So when we do that, is opposite b. So if b is -10, we're going to take opposite of that. So it's going to give me a +10. And then plus or minus the square root of b squared. Well, in this case, I'm going to plug in -10 squared minus 4ac. This is b4 times a, which is equal to 1, times c, which happens to be equal to 9. And then you're going to put it all over 2a, which is all over 2 times 1. Okay? So once again, a, plug it in. That went in there, right? And there. B, we plugged it in. B was a -10. That went in under the square and then in front. And the last thing we need is the value of C, which in this case was the 9, which we plugged in there. Everything is multiplied according to the formula. Okay, now all we need to do is simplify it, kind of like we did in the first exercises, and then we're done. So when we simplify this, we get x is equal to 10 plus or minus the square root of -10 squared is 100. Subtracted by 9 times 4 is 36 times 1, which is still 36. And then you're going to put it all over 2 times 1, which is 2. So once we simplify that, we're basically done. So it's going to be x is equal to 10 plus or minus the square root of 100 minus 36. 100 minus 36 is 64. So it's going to be 64 square root, and then put it all over 2. Finally, we can simplify this a little more. X is equal to 10 plus or minus the square root of 64 is equal to 8, and then you put it all over 2. Which means that we're going to have two different answers for x. Some of you guys are ahead of me. 10 plus 8, which is 18, divided by 2. And the other answer will be 10 minus 8, which is 2 divided by 2. So one of my answers is 1, and my other answer is 9, which we knew, right? So the two values of the roots are x equals 9 and x equals 1. 9 and 1. You see that? So we solved it two different ways, by the quadratic formula by using the zero product property. Now, if you want to double check it with the decimals graphing calculator, which I love to do all the time just to be safe, if you plug in x squared minus 10x plus 9, we get this, x squared minus 10x plus 9, which happens to have two roots. One of the roots is there, add 1, x equals 1. The other root is there, add x equals 9. No big surprise here, right? So you could always check your work using Desmos. My other two examples, again, I recycled these from the last assignment. Let's try to figure out what the roots are by using the quadratic formula for this. First thing you need to make sure of is that this is in standard form, which it is not. So standard form means we have ax squared plus bx plus c, right? In this case, this is backwards, so we need to swap the two in the correct order. So let's actually flip them. So we're going to have x squared. Let me change the color back to black. So x squared minus 2x and then minus 4 equals 0. Now that I have that, I could actually identify my a, right? So my a here is equal to 1. My b here, now that it's in the correct order, is equal to -2. And then my c, the number without any variables, is -4. So now that I have these three values, so a is equal to 1, b is equal to -2, and then c is equal to -4, I can plug it into the formula that I have memorized, right? So the quadratic formula is the following. X equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. So when I plug it into the formula and simplify, I basically get my solutions or my roots. So let's do it. Okay, so opposite b, that would be opposite of negative 2. So x equals opposite of negative 2 will be positive 2. And then plus or minus the square root of b squared, this will be negative 2 squared, minus 4 times a, which is 1, times c, which is negative 4. And then once you're done, you put it all over 2 times a, which is 2 times 1. So once again, just to backtrack, I plug in a, which was 1, into there and there. So that came from there and there. I plugged in b, which was in front, right there and right there. I made it opposite according to the formula, and I also plugged it in there. And then finally, I plugged in c, which was negative 4, and I multiplied it here. Okay, so plug in a, b, and c. That's all we're doing. Then we just have to simplify this, and then we have our roots by just plugging it into the formula. So it's going to be 2 plus or minus the square root of negative 2 squared will give me 4. Negative 4 times 1 is just negative 4, and then negative 4 times negative 4 is positive 16, so this will be plus 16. On the bottom, I have 2 times 1, which is just 2. So then this becomes 2 plus or minus the square root of 20, right? Because 4 plus 16 is 20, and then you put it all over 2. So this is my final answer. If it bothers you that you're looking at the answer this way, you could actually simplify the radical just a little bit. A lot of math books, if you leave it like this, it will consider it not simplified. So the radical 20, if I simplify this on the side somewhere, radical 20 will be 2 times 10, right? And this will be 5 times 2. I actually have a pair of 2's, which means that I can take that on the outside, and I can leave this 5 on the inside. So this radical 20 becomes 2 square root of 5. So I'm going to go ahead and replace that with the value of 2 square root of 5. And then I put it all over 2. Well, when I put everything over 2, look, the 2 and the 2 cancel for both of them, right? If I divide everything by 2, 2 divided by 2 is 1, 2 divided by 2 is 1. So basically the 2's cancel. I'm left with x is equal to 1. Let me put it on the other line. So x is equal to 1 plus or minus square root of 5. So these are my two answers. Now, if you're wondering what that is, if you pop that into your calculator, you're going to get two answers: square root of 5 plus 1, and then 1 minus square root of 5. So I'm actually using my phone calculator because I learned from my mistakes. So 1 plus the square root of 5 is 3.23. So one of the answers is, oops, sorry about that. One of the answers is 3.23. Plug it into the calculator. The other answer is the same exact thing, but it's going to be 1 minus the square root of 5. And that gave me negative 1.23. So my two roots should be these two. But if you look at it in your math book, they'll probably give you something like this. But if you want to check it with Desmos, Desmos does decimals, so you want to get something like this, as in the decimals. So when I plug it in to Desmos and I graph it, I graph this, x squared minus 2x minus 4. So x squared minus 2x minus 4. It gives me this graph, so it's a parabola going upwards. There are two roots, right? Two x-intercepts. So this is my first root, my first solution. This is my second solution. And what do you know? The first one is negative 1.23. The second one is 3.23. And those are exactly the ones that I got when I did the quadratic formula, right? So first root was 1.23, and the second one was 3.23. Okay. So next up, example 3, which is the very last one. Same thing. We want to solve the quadratic equation by using the quadratic formula. Sorry, not completing the square. By doing the quadratic. See, I told you guys to recycle this. By doing the quadratic formula. And then verify the result with decimals if you can. So first thing we need to do is identify a, b, and c after we set the equation equal to 0, which it is not. So before I even start anything, I'm going to subtract 10 from both sides to get that equation equal to 0. Because remember, in order for me to plug it into Desmos or to even solve it in general, I got to make sure that equation is set equal to 0. Okay, now that I have the equation set equal to 0, now I can start thinking about my values of a, b, and c. So the number in front of the x squared is a 3. So I'm going to say a is equal to 3. Notice that it doesn't really matter that it's not a 1 because the quadratic formula will work for any number no matter what. The value of b is the number in front of the x, which in this case is -6. Don't forget the negative. And then the value of c is the number that doesn't have a variable, which in this case is -34. So yeah, the numbers are kind of obnoxiously big, but it should work if we plug it into the formula no matter what. All we need to do is memorize it. Okay, so the quadratic formula says the following, that if we're trying to find the roots of this, the roots will be x is equal to opposite b plus or minus square root of b squared minus 4ac, and then all divided by 2 times a. So all I have to do is plug these values into the formula, and then I have my values for my roots. X equals opposite b plus or minus square root of b squared minus 4ac all over 2a. So when I plug this in, I get opposite b, which is opposite of -6, so that'll give me just a 6. And then I have plus or minus the square root of -6 squared, so I'm going to go ahead and write in -6 squared. And then minus 4, that's part of the formula, times a, which happens to be 3. And then times c, which happens to be -34. All right, almost there. And then we divided all over 2a, which happens to be all over 2 times 3. Okay, so make sure everything is plugged in correctly in the right spot. So a goes there and there. The b, which I colored blue, goes there and there. And then c goes only in one spot, which was at the very end, multiplied with the -4 in the a. Okay, if you plug everything in, all we have to do is simplify it and we're done. So let's simplify. So x is going to be equal to 6 plus or minus the square root of -6 squared will give you 36. Minus 4 times 3 times 34. I'm going to have to use a calculator for that. So 4 times 3 is 12. So it's 12 times 34. And if we multiply 12 times 34, I get 408. So that'll give me 408. Positive. Notice that it's positive because the negative and the negative cancel out. And then on the bottom, I get 2 times 3, which is 6. Okay, 408. Now I have to add the 36, right? So we got to simplify the parentheses. So 36 plus 408. My calculator tells me that it's 444. So it's 6 plus or minus the square root of 444. And then all divided by 6. Okay, now let's see if we're able to simplify that square root of 444. If we can, great. Let's do it. If we can't, then I don't know. I guess we can just move on. So square root of 444. Let's try to factor that out. So when I check this with my calculator, it tells me that 444 can actually be factored out if I do 12 times 37. Now 37 is a prime number, so I can't break that up anymore. But 12 I can break up a little more. So 12 can be broken up as 4 times 3. 4 times 3 is 12. And then 4 can be broken up a little more into 2 times 2. So I have a pair of 2's, which means that I can actually take that 2 and put it on the outside. And then whatever's left over on the inside, I mean, big whoop, it just has to stay inside. So the 3 times 37 stay inside. So 3 times 37, 3 times 37 is 111. So I'm going to have the square root of 111 on the inside, because that was 3 times 37. And the 2 came outside because it actually had a little buddy to go out with. So that means that when I simplify this, it's the same thing as if writing this. So I'm going to go ahead and write that on the right-hand side. So it's going to be the same thing as 6 plus or minus 2 square root of 11. Oh, sorry, square root of 111, and then all divided by 6. So I really can't do much here except for just simplify the fraction by dividing by 2 top and bottom, right? Or actually, yeah, I can actually divide this by 2, and then I can actually divide this by 2 and break it up a little bit. So let's do that. Let's simplify it really quick. 6 divided by 6 is just 1. So 1 plus or minus 2 over 6 is just 1 over 3. And then the top stays the same as square root of 111 divided by 3. So you can write it like that. Or if you wanted to write it the other way, in the sense that we basically just leave it as one giant fraction, we just divide by 2 top and bottom, you can write it like this also. You can say this is 3 plus or minus square root of 111, and then all divided by 3. Either way, it's the same exact answer. You have two answers, right? X is equal to 3 plus square root of 111 divided by 3, and then x is equal to 3 minus square root of 111 divided by 3. If you pop that into your calculator, you will get two answers, and those two answers happen to be what you plug in when you plug it into Desmos. So the two answers are, according to my calculator, 4.51. So 4.51. That was one of the answers when I plugged that in. The other answer is negative 2.51. So in any math book, like I said, you probably will look at it like this, right, as your solutions. But if you actually do the math and you get a decimal, it's 4.51 and 2.51. So when I plug that into Desmos, or actually the second one is actually negative 2.51. When I plug that into Desmos, right, so if I want to try to graph it, I want to graph the part set equal to 0. So in this case, I would graph this piece, which is 3x squared minus 6x minus 34. I plug it in, I get a quadratic, right? That U-looking shape quadratic function, which is a parabola. If I check my roots, it's negative 2.51 and then positive 4.51, which is the exact same thing that we got when we used the quadratic formula. So quadratic formula works every time. Hope this video was helpful. Enjoy your summer.